In this video, we'll take a look at the very last problem on the quiz from sections 2.6 and 2.7, and it was one where I said that this formula, cosine of 2t, was going to determine the position of an object moving along a line at time t. I want to find a velocity function for this object. I want to find an acceleration function for this object. I want to use those to determine if the speed of the object is increasing or decreasing at t equals pi by 12. So this is the problem on the quiz that's going to require the most work. To get started, you have to recognize that if this is a position graph, the derivative of position's velocity and the derivative of velocity is acceleration. So my velocity function is going to correspond to f prime of t, the derivative of position, and the derivative of cosine is negative sine. I'm not going to put an x here, I'm not going to put a t here, I'm going to put the inner function here. So 2t is within that sine function. And then I need to finish the chain rule by multiplying by 2. Now since I'm going to do a little bit with this derivative, I'm just going to clean it up a little. It doesn't really simplify too much. I'm just going to shuffle the order of this multiplication around a bit. I'm going to put this 2 out in front of the sign, connect the negative with it. Just looks a little nicer writing it this way. And since we're taking another derivative, I would rather have it written like this. We need another derivative because we also need an acceleration function. So acceleration is the derivative of velocity, or the second derivative of position. So I'm going to have to take the derivative of this. You do not have to use the product rule on this, because if you take the derivative of negative 2, you get 0. So half of your product rule is going to drop out. The only half you're going to have is going to be negative 2 times the derivative of sine of 2t. So I'm just going to copy down the negative 2, and then I need to multiply this by the derivative of sine of 2t. So the derivative of sine is cosine. I'm not going to put an x or a t here, I'm going to put the inner function here, and then because that's an inner function, I need to finish a chain rule and multiply by the derivative of the inner function. And again, since we want to do a little bit with this, I'm just going to clean it up a little. I see I have a number here in this chain of multiplication. I'm just going to multiply those two values together, and I'm going to write my acceleration function as negative 4 cosine of 2t. Okay. I wanted the velocity and acceleration functions so that I could say something about the speed of the object at pi by 12. Speed is the absolute value of velocity. So I'm going to start by finding the velocity at pi by 12. So the velocity at pi by 12 is going to correspond to pi by 12 tossed in place of this t. So we're going to have negative 2 times the sine of 2 times pi by 12. This is something that you'll be able to use the unit circle or the left-hand trick to help you with, as long as you simplify this properly. If you do top times top, you get 2 pi. Bottom times bottom, you'd get 12. 2 pi over 12 would reduce to pi over 6. So this would be negative 2 sine of pi over 6. Now if you use the left-hand trig trick to help you figure out what pi by 6 is, use your left hand as the first quadrant of the unit circle, and we're looking for sine of pi by 6. So that's going to correspond to this angle right here, right? This would represent pi by 6, pi by 4, pi by 3. So I'm going to pull in the finger that represents the angle pi by 6. And since I'm looking for sine of pi by 6 and s is below c in the alphabet, I'm going to count how many fingers I have below the one I pulled in, which would be 1. I'm going to put that value underneath a square root. So 1's under a square root and it's being divided by 2. And if you simplify this, what you end up with for the velocity at pi by 12 would be, well, if you do top times top, bottom times bottom, you get negative 2 over 2. You end up with negative 1 for that velocity. I also want the acceleration at pi by 12, because the absolute value of this would be 1. So you might say, well, speed is positive, so speed is increasing. But if the next velocity just after pi by 12 is like negative 1.2, that would mean velocity is becoming more negative, and the absolute value of velocity would be increasing. But if the next velocity is like negative 0.9, velocity is getting closer to 0, so the absolute value of velocity would be getting smaller, and then speed would be decreasing. So you do need to know what the acceleration is at pi by 12 in order to answer questions about speed. So I'm going to put pi by 12 into my acceleration function, so that's going to be 4 cosine of 2 times pi by 12. And just like we did before, we can multiply 2 and pi by 12 together, and when you do that, you're going to get pi by 6. So you can use the left hand trick again, and it's still the same angle, so angle pi by 6 would be right here. C is above S in the alphabet, so we'll count how many fingers are left above, and that would be 3. We're going to put that underneath a square root, and it's going to be over 2. And if you simplify this, if you do top times top, bottom times bottom, you end up with negative 4 square root of 3 over 2. The negative 4 divided by the 2 would leave you with a negative 2 square root of 3. So acceleration is negative, velocity is negative. What does that tell us about speed? Well, if you do a quick sketch of the velocity graph at the t-value of pi by 12. Let me zoom back in. I realized I zoomed out to do the left-hand thing, so get you back in here a little closer. So at pi by 12, we've determined that velocity is negative 1. So velocity is going to be negative. At pi by 12, we've determined that acceleration, which is the derivative of velocity. So on a graph, acceleration would represent the slope of the tangent line on the velocity graph. We realize that's also negative. So we have a negatively sloped tangent line at this point. Now I don't know what the rest of the graph looks like around this point, but I do know that this is the velocity value at this t value, and that the slope has to be negative because acceleration, the derivative of velocity, was negative at that point. So if you think about what's happening with velocity here, velocity is moving away from 0, right? It's becoming more and more negative as you cross the t-value of pi by 12, or as you're at the t-value of pi by 12. And because of that, what we're going to have to conclude with is that the absolute value of velocity is getting larger since velocity is moving away from 0, and therefore speed would be increasing.